So I sent out a couple GC activities, and both are designed to get you acclimated to using GC. One of them is more specific about the graphing capabilities, and one is more about defining functions and using the calculator aspects of it. So I want to go over one of those as a large group, and I want to go over the other. The other one's a little more self-paced, so I'm going to put you in the breakout rooms for about half the period. So I'm going to go ahead and share my screen. But for now, open up the coordinate point activity that I sent out. That's the one we're going to start on first. So basically, there are a few things I'm going to demo, and then I want you to try to recreate them. So it might be helpful also if you have, especially if you haven't done much with GC as of yet. I sent out a couple of cheat sheets, one for Windows, one for Mac, that will help you. It has a bunch of the keyboard shortcuts on it that you can refer to. If you didn't save it from that email, or it might be a little easier to find it on Canvas. I believe one of the very first announcements for the class from Mark Ashbrook contained those two cheat sheets. All right, can everyone see my screen? Hopefully the silence means yes.
Yes.
So here's the first thing I would like you all to work on. So I have a graph here, and right now all you can see on it are these 3 fixed points. So let's just do this. Graph those 3 points. So there's a command, there's a keyboard shortcut that can basically bring up the command that helps you do that. There is in one of the drop-down menus, you can find something that will help you do that. But for now, let's focus on graphing those 3 fixed points at the proper coordinates. And if you could do me a favor, use the thumbs up reaction to let me know that you've gotten this to work. All right, do we still need a minute here? All right, so someone tell me what command they use to get this to happen.
Control-2.
Control-2. So yeah, that's the keyboard shortcut for it. And I also see a couple people seconding that in the chat. But yeah, Control-2 brings up what's called it's a 2-dimensional vector. So you'll get a column vector that gives you 2 coordinates. Or if you prefer, if you go into the math menu, you can find a 2 vector or a 3 vector or whatever that way. Any questions on that one? All right, so that'll come up a lot as you do things in GC. Sometimes, I think and hope by now that all of you have graphed functions, but I'm not sure if yet you've been asked to graph single points. But that will be a useful thing to get in the habit of. All right, next thing I'm going to ask you to do is this. By the way, if, you should not, this caused a little confusion in my last section. You will not see this slider at the top of my screen. I have a slightly different file than you all.
I was just about to ask about that.
Yeah,
I was going to say, like, where is this?
Yeah, my file is meant to kind of lead you through these exercises, and yours is more of a blank slate. I already have all the commands programmed in. Yeah, but that slider, basically I can hide things and show them to you as I want. So this one here, now that I've made more of this visible, I am showing you part of a graph. So I am not going to tell you what this function is. Hopefully the fixed points, the coordinates of those 3 fixed points you graphed, will clue you into what the function is. We chose those intentionally to help you there. So 2 things: graph the correct function, but also I only want you to graph the part of it that I'm showing you. So I think you learned from the first GC assignment you did that if you graph a function, GC will just graph it over the entire domain that it's defined on. This function is defined on a much larger domain than what I'm actually showing. So one of the things I'm asking you to do is to restrict this to the values that I'm showing you. And again, give me a thumbs up when you've got that to work. So Ash, you're asking how to graph the points. I'm going to show those to you again. So to get these column vectors to show up, you can go one of 2 ways. One is just hold Control and hit 2. Oh no, to make the line. So after you define something, so I'm going to answer the question I think you're asking. You have entered the command to make the graph, but it's not actually making the graph. If it's the right command, all you should have to do is hit enter, and it'll generate it. And there you go. Yeah, Dylan. If you do y equals and then the equation there, it'll do the proper graph. So yeah, make sure you give me a graph that goes through all 3 of those points, and also give me a graph that's actually restricted to that area there. And just kind of give you another hint on the equation here. So keep in mind the 3 fixed points. When x is 1, y is equal to 1. When x is 4, y is equal to 2. When x is 9, y is equal to 3. Think about what operation or operations I can do to 1, 4, and 9 to get back 1, 2, and 3.
So do we have to put in those points, the 1, 1, 4, 2, and all that manually, or is that already in there?
No, you'll have to do it manually.
Okay.
So yeah, it's in my. I've made this one ahead of time, so I can show you what I am asking for. All right. Who wants to give me a command for this one? How do we make that graph like that?
It's y equals the square root of x, and then you do 0.5 is less than or equal to x, which is less than or equal to 10.
There you go. Very good. So I'm going to show you what my equation looks like. It's going to look a little bit different. You don't need that if view is greater than 0. that has to do with the slider that I have here. But yeah, that's exactly right. In fact, even though it'll break the functionality, I'm going to go ahead and delete that. Try to anyway. Only difference I have between mine and what was said was that I don't have less than or equal to. I just have less than. But it's not gonna really change how the graph looks. So, any questions on either the first two things, like how to make the fixed points and how to make the graph, and how to restrict it to a certain set of x values? And Rand says you can write code into GC. So yeah, GC is it's more powerful than it might appear at first. So you can put in logical statements to do some more sophisticated things.
We'll be recording this, right?
I already am, I believe.
Okay, good.
Yeah. Yes, I am. Okay. All right. So next thing I want to do is the movable point. So let me slide this back up. So when I put this thing on its rightmost setting, you should have seen a black point show up on this curve. So I can do a couple of things with this black point, this movable point. When I drag the slider around, the point moves around, but it stays on that curve. Another thing I can do, I can just hit the play button down here and it'll move around on its own. It'll basically just go back and forth. I'm going to make this a little less green. That's a little faster. Okay. So this one, I don't think you've done anything like it yet, so I will give you a little more hints here, a little bigger hint here. So I think Mark mentioned this in class sometime last week, but you can call a variable in GC pretty much anything. For example, I have a variable here called view. So it can be multiple letters, that can be full words. The only exceptions are there are some characters that are reserved for certain things. For example, X and Y. Like you can't use X and Y to be any kind of constant or anything. X and Y are used primarily for graphing. If you do Y equals square root of X, for example, that's going to do a graph. It would not do a graph if you used any other letters there. One of those reserved letters in GC is N. So basically, N is a parameter. So basically, I think it's pretty clear that this black dot here that's moving around, its definition has something to do with the function y equals the square root of x. But basically I can, depending on what the value of n is, I can make that point anywhere. So hopefully this isn't too big of a hint, but I'm going to give it to you anyway. For the first part of this, what I asked you to do is give me fixed points. So you gave me 1, 1, 4, 2, and 9, 3. Now what I'm asking you to do is give me a point that's not fixed. So a point that can be anywhere on this curve. So I'll give you a couple minutes to think about that, and then I'll get that command from somebody. Hey, Jerome, I understand the graph button's grayed out. It is for me too. What happens if you just hit enter after you type in the command?
Well, only the dots show up, but yeah, there is no line connecting them.
Okay, so for this one, do you have does yours look just like that?
Oh, I haven't typed in the equation though. Do I need that one to?
Oh, so if you don't have the graph, then yeah, that's important.
Okay, my bad.
Mm-hmm. So yeah, just a reminder, the file I sent you is mostly blank. Mine is all pre-built. Layla, at the end of class, I'm going to put you in touch with the woman who does she does a lot of tech support, among other things, for the math department. I have not heard of that error, so hopefully she can help you with that. But that's really frustrating. All right, anybody got this to work? The moving points. Okay. Got a couple. All right, so it's very related to how you do fixed points for those of you who haven't gotten there yet. So fixed points, you need a 2 vector and you need constants. Because you just have to tell me where the points live. The movable point is a little different, but only a little. So I need a 2 vector still, but instead of having constants for those 2 coordinates, I want my x coordinate to be n, I want my y coordinate to be the square root of n. So basically you're kind of defining your function in a different way. Again, don't worry about that if statement. That's not going to apply to you. This just has to do with my slider up there. Any questions on this movable point? So the movable point, if he hasn't already assigned it, I think it'll come this week, but there is, that's something you will be asked to do, is to use a movable point and to make it do a few certain things. All right, any questions before I have you do one more thing here?
Yeah, if there's multiple variables, would you use something else then if you're graphing like 2 equations, let's say?
Sorry, can you say it again? You were a little quiet.
So if there's 2 different variables that we have to use, would n still be used for both of them if we're going to do the moving points for both of them?
So when you're doing the moving point, basically n is really the only parameter you have access to. But in this case, even though you have a function in 2 variables, since you have a definition for a function here, you really only need to use n.
Okay.
Is that what you were asking?
Yeah.
Okay, good. And Layla, which part would you like me to re-explain? All right, the movable point. So movable point, bottom line is this: if you want to make any point, any single point in GC, you need a 2 vector. So again, that's under the math menu, 2 vector, or you can use the shortcut control 2. The difference is with the fixed points, you actually need to type in the numbers. You need to tell me like where those points are, and they're not going to move unless you change the coordinates. For a movable point, you need to define them in terms of some kind of parameter. So since I want to mimic this function here, I'll just let my x value be n. And for any x value that my movable point takes, I want to take the square root of it and call that my y value. So that is why that movable point only goes back and forth on the curve that I already drew. You can find the recording of this class. I'll send out the YouTube link when these videos get posted. But those of you who still have that YouTube link, I'm going to post everything to the same place, so they'll just show up there sometime today. All right, the last thing I want to show you is this. I'm going to go ahead and turn off the axes. So now where the X and Y axes were, you now see a red line and a blue line. And those are connected to my movable point. So as I move my points around, I'll just hit the play button to let it move. As that movable point goes back and forth, you can see the blue line shows you basically how far that point is from the y-axis. And the red line shows you how far that point is from the x-axis. So my last task for you here is to make those red and blue lines.
I had a good question. How do we keep the point from going to 0? Like, how do we keep it like?
I don't actually think you can.
Oh,
in fact, mine goes to 0.
Right, mine was too. I tried putting like a domain on it, but it wasn't like, it didn't work for a moving point.
I click this N here. Oh, never mind. I think it can be done. Let me see this. 0.5. Let me see if that did anything. So if I grab this and take it all the way back, okay. So what I said couldn't be done is very easily done. So this, at the very bottom of the screen, you can click that N button and the slider values come up. So basically you can set your minimum value of N, maximum value of N. The number of steps is basically how fine it is. You can make it more accurate, less accurate. All right, I'll just go ahead and play again. Yeah, let's go ahead and try to make those red and blue lines. And give me a thumbs up when you think you got it. All right, someone want to give me a command that made this work? Or pair of commands? I don't think I did this in only one line. All right, so in the interest of time, seems like y'all are kind of shy right now, so I'll show you what I did. So at the very bottom here, so y equals 0. Just to recall, what is y equals 0 the equation of? If I were to just graph y equals 0, what's that going to give me?
The x-axis?
That's the x-axis, right. So basically this blue line here graphs the x-axis, As far left as 0 and as far right as the sliding point is. So similarly, the next line, x equals 0 is the y-axis. So that will graph the y-axis as low as, so it'll graph the y-axis as low as 0 and as high as the square root of n. So you get those two things working together and you get a red and blue line that basically follow that moving point, give you a total change in x, total change in y for any point on that curve.
I didn't get that at all. Like you just scrolled down on like the command like functions, right? Like that you already gave us. Yeah. Do we change the A's to zeros?
Oh no, don't change these. In fact, so just to reiterate, your file does not have this built. Mine was I prepared mine ahead of class.
So we add those new command lines below the do not change the line? Gotcha. Okay.
Right. Mm-hmm. How do you add the red and blue squares? If you are not seeing those, then that is because, and this is one thing that's also pretty important in GC. So when you're entering a line in GC, you can do one of two things. It's either going to be a math line or it's going to be a text block. So if you want to do a math line, so I'm at the very last line of my document here. So I want the next line to be some kind of calculation or a graph or something in math. So I'm going to hit Control Enter. And you can tell it's a math line because it has one of those colored squares before it. So and the square goes away because I don't need to assign a color to it. All I did was a calculation there. If you're not doing a math line, you can also do just a text field. So I'm going to do Control T. So this is just text. Like this down here is not going to do anything. So basically, when you're making notes or just kind of commenting or describing what's about to come, you do a text line. So if you don't have that square, and you'll also notice the fonts are a little different. But I'm guessing if you did the move to a next line and didn't get that colored square, it's because you were on a text line.
I have a question.
Hold on, I got a question in the chat. I typed in exactly what you have and the lines aren't showing up. So to Dylan and Ash and Shannon, did you hit enter?
Make sure you guys aren't doing Y and Y on the same line. It's YX. That's what caught me the first time.
I mean, like I have it typed in exactly like you did, and it's like I can see the red line kind of like barely going up, but I can't see the blue line at all.
Okay. And you have the same colors as I do?
Yes.
Did you turn off your axes on the graph?
No.
Okay. So that might be why, because the black and the dark blue might be hard to distinguish.
Okay.
So if you go to graph and then uncheck draw axes.
Okay.
Hopefully it'll be a lot more obvious. Cool.
Okay.
Good. All right. Any questions about any of this that we did on here? Okay, so just a taste of a lot of the things you can do with graphing here, and you'll get more practice as the semester goes on, but I know some of these things you're going to be asked to do pretty soon. So I'm going to go ahead and stop sharing. Now let's move on to the box cost one. And since I'm about to put you into breakout rooms, I'm going to stop the recording.